Hello, this is our final project presentation for CSE 564 visualization. So we are group 103 and our topic for this project is analysis of global statistics and its impact on GDP. So coming to the goals of this project, usually a country's gross domestic product is generally calculated using several factors, including revenue from our private consumption, from gross private investments, government investment, and government spending on exports and imports of that respective nation, so on. So it is important that to note that there are several number of indirect factors that are not considered when computing GDP, but have an indirect effect on the nation's GDP in either a short or a long term. So using a dashboard titled Global Statistical Analysis, we aim to develop an interactive user interface that can be used to analyze the trends on change in the GDP based on factors affecting it directly or indirectly. Coming to the dataset used in this project, we have derived a dataset from the source rworld in data.org, basically denoting various statistical attributes upon which we are trying to find the underlying relationships. So the data for this project was compiled from a variety of individual independent datasets through automated scripts followed by the regular data pre-processing techniques. So some of the attributes that we have considered for this project are GDP, population, life expectancy, annual CO2 emissions, homicide rates, mortality rate, tourism, terrorism, etc. Yeah, so here is a dashboard titled Global Statistics. It basically comprises of six main elements or plots denoting our data. Coming to the first plot, this is nothing but a choropleth map that shows a divided geographical area or region that are colored, shaded, or patterned in relationship to the data variable. This provides a way to visualize values over a geographical area, which can show various patterns across a displayed location. So in this plot, we have visualized several attributes like annual CO2 emissions, life expectancy, tourism, etc., based on the attributes that the user tends to select to see how different nations are placed with respect to the selected attribute, gauging their intensity of the color assigned by the choropleth map. So, for example, if we consider GDP, hovering over a particular nation would convey its true value of GDP through the tooltip feature that we have implemented and would assign the color accordingly relative to the value of the other nations. So coming to the features implemented as a part of this plot, we have added the zoom feature for the user to be able to select the country which are comparatively small in the map while interacting. And also we implemented the dynamic scaling feature that displays a legend in order to save the space in the dashboard layout, where the scale legend in the map would dynamically scale up and down according to unique set of values that the attribute possesses. So lastly, we have also enabled the multiple nation select feature for the user to select different combinations of countries in order to visualize the selected filtered selection and on the consecutive plots in the dashboard through interaction. So whenever the user interacts with the map elements, the time series plot, bubble scatter plot, and the parallel coordinates plot would change or scale accordingly. So coming to the next plot, which is donut chart. Donut charts is essentially a pie chart with area of the centered cutout. We usually represent the proportions of categorical variables through donut charts. But for this project, we have restructured the donut chart to be used as a feature selector or a menu or an attribute selector menu for the user to be able to select different attributes where he or she desires to drive the interaction. So coming to the features of this donut chart, we have animated the selection of the pie or the sector in the donut chart, which basically denotes an attribute, and the center of the circle area displays the selected attribute statistics or info depending upon what the user clicks. And upon clicking the center area, we can reset the selection of the user. So whenever the user interacts with the pie chart elements in the donut chart, the time series plot, the bubble scatter plot, and parallel coordinate plot would be changing accordingly. Yeah, coming to the racing bar chart. Upon interaction with the donut chart, based on the user selection, we initiate a racing bar chart. In this use case, the user has selected annual CO2 emissions. A race bar chart is a great and highly visual way to display data changing over time from in the form of an animated bar chart. It is very comprehensive representation of the time-based change in the data. Here we can see the top 10 nations with respect to the attributes selected that are scaled as time progresses between the time frame 1995 to 2019. So coming to the features of this racing bar chart, we have implemented a replay feature that reinitiates the racing bar chart again and again amongst the top countries based on the attribute selected. And we have also added a back button feature that enables the user to switch back to the donut chart to change his selection. So next, my teammate Akila would summarize on the remaining plots in the dashboard.
Moving to the bubble scatter plot, A bubble chart is a variation of scatter plot where the data points are replaced with bubbles and an additional dimension of the data is represented in the size of bubbles. Here we have constructed a bubble scatter plot where the x-axis basically denotes the GDP and the y-axis represents the attribute selected by the user through the donut chart as mentioned earlier. Here all the above data points are grouped based on population, which represents the third dimension that is categorized by the size of bubble. Coming to the features of this plot, we have implemented a tooltip for the user so that they will be able to hover a particular bubble and see its stats with respect to GDP, population and the selected attribute. We have also enabled the brushing feature where the user can brush over a particular subset of data points and see the filtered data in the remaining plots for finding out hidden patterns. Moreover, the user can also pan the brushed window all over the bubble scatter plots for easy filtering and interaction. Moving to the time series line chart, trends in quantities or numerical values over time can be visualized using time series graphs. So using this graph, we have visualized several attributes like annual CO2 emissions, life expectancy, tourism, and other attributes with respect to time. So this visualization provides information on how each property changes over time. Here, each point on the graph represents both the time and the measured quantity. Coming to the features implemented in this chart, we have enabled the brush functionality for the time series chart and thus user interaction dynamically updates the world map and bubble scatter plot and PCP plot. Using this, the user can select a certain time interval and brush the time filter graph over the fixed interval to view how other plots interact during that particular time frame. Next is a parallel coordinates plot. So the PCP plot is basically used for plotting multivariate and numerical data, and parallel coordinates plot are ideal for comparing many variables together and seeing the relationship amongst them. So here we have visualized all the attributes along with the GDP for all the nations in the world in order to find the correlation between the attributes and also see how the set of countries amongst them are whether positively correlated or negatively correlated. So coming to the features in the PCP plot, we have added the tooltip feature in the PCP in order to view the attribute related data for that respective nation, because due to multiple paths in the PCP, it usually becomes difficult for the user to parse the data points. Moreover, we also enable the brushing feature in the PCP, which lets the user highlight certain subset of points, which would enable them a clear picture of the correlation with respect to the attributes and different nations. So these are the main elements of our dashboard. And now let's discuss the flow and insights by selecting an attribute. In order to find the insights, let's consider annual CO2 emission as the parameter. So once we select an attribute in the donut chart, we initiate the racing bar chart to visualize the top 10 countries which are leading producers of CO2 emissions amongst all other nations. From initially observing the racing bar chart, we can see that US was producing the most CO2 until 2006, which was then overtaken by China. Similarly, Russia was in the third place during the year early 90s, which was then surpassed by India in recent years. We can see that China, US, Russia, and Japan and Germany are one of the top 5 producers of CO2 emissions in the world compared to the other nations. Let us deep dive a bit further on these countries to gauge its impacts on GDP. Using our choropleth map, we can filter out these top 4 nations to see their respective data points represented in the other plots. Coming to the time series chart for these nations, we can see that overall trend for these above nations seems to be increasing over time. But let's see their individual behavior with respect to CO2 emissions. For that, we can brush the bubble scatter plot on the filtered data for visualizing how the individual country shows the trend with respect to the CO2 emissions. We can see that upon brushing the nations, US and Germany, they showed a downward trend, that is over time it reduced CO2 generation, whereas China and Russia showed exponential production of CO2 emissions in recent years. Japan, on the other hand, started with low trend CO2 emissions that increased in the time frame 2010 to 16 and started declining over time recently. We can visualize the same behavior in the scatter plot by taking 2-year time frame and brushing it over time in the time series plot, where we observe that over time US, Japan decreased their emissions, whereas China and Russia portrayed the inverse trend, which is an inverse in the CO2 emissions. From the above analysis, through these plots, we can deduce that US economy initially was directly correlated to GDP. That is, GDP increased as CO2 emissions increased, but as the time went by, US focused on decreasing CO2 emissions but continued the increasing trend in GDP. Whereas for China, CO2 emissions showed direct correlation with GDP until the saturation point, after which increase in CO2 showed no change in GDP. It may be due to a heavy investments in industrial sectors which led to greater CO2 emissions, but in long term it is not beneficial for the nation. To generalize this trend, that is to know the correlation between GDP and CO2 emissions for all the nations, we can interact with the PCP plot and see that there is a direct positive correlation between GDP and CO2 emissions. Similarly, we can follow the same flow of interacting with the plots while finding the insights for other attributes. So this is the overview of our dashboard. Thank you.